students, this is Sakshi Ganotra, a faculty at askIITians. I have been enrolled here with askIITians since last 2 years. So today what I have chosen to discuss with you people is a very good topic, thermodynamics. Now this thermodynamics topic is very generally asked in the exams. So either it is IIT-JEE exam, it is a medical exam. This topic thermodynamics is very useful for every kind of questions. Now in this topic, I have thought of discussing with you people something known as what are system, what are surroundings. So first I'll tell you how the universe is divided into system, surrounding and the other parts. Then I'll try to discuss the most important properties which are related to thermodynamics. Then we'll consider what are the different laws of thermodynamics. After the discussion of the theoretical stuff, I'll try to come over to what are the applications of thermodynamics. And once we'll discuss the applications of thermodynamics, I'll try to teach you certain questions which have been asked in the previous year IIT exams. So, in the first part, I'll be telling you the basic terms which are used to know what thermodynamics actually means. Let's start with the discussion of the first part. So, coming over to the topic, let's move over to the topic named as thermodynamics. Let's first of all discuss what are the topics that I'm going to cover in this chapter, thermodynamics. So this chapter will be including the topics as thermodynamic systems and their types. So we'll be studying about what are the different kind of thermodynamic systems and how can they be classified. After studying this thing, we will move over to thermodynamic properties and the processes. So to know what are thermodynamic properties, what are the processes which are covered during the so-called chapter as thermodynamics, we are going to take the details of all these things into account. Finally, once we are done with the kind of processes and the different properties of the system, we'll go over to the thermodynamic laws, where we are going to discuss the different types of laws that have been proposed to study thermodynamics. Now, after studying the laws, we'll study something which is of practical importance to us. And if I'm simply talking about the stuff which is for practical importance, that needs to be covering heat engine and Carnot cycle. So now, as if I have given you the details of whatever I'm going to discuss in this chapter, let me begin with the chapter. So here comes the first part of the chapter where we are going to discuss about the basics of thermodynamics. So if I'm talking about thermodynamics, let me first of all tell you that thermodynamics is made up of two words. One is thermo and the other is dynamics. Now, thermo, as we all know, is something related to thermal energy. Thermal energy is again, the core comes from something known as heat. And dynamics means flow. So dynamics actually means power. If I take into the dictionary meaning, dynamics means power. So thermodynamics is basically that class of science, it's that branch of science where we are going to discuss about the flow of heat change. Like how can heat be given into the system, how can heat be given out of the system. So when I'm going to discuss this flow of heat into and out of the system, this is what is being dealt in thermodynamics. Now since we have covered the basic definition of thermodynamics, let me define something known as system, surrounding and boundary. Now as we know, to discuss any wide topic, we need to start with the core basics. So this core basic of thermodynamics is dealing with the system, the boundary and the surroundings. Let me take an example. Suppose there is a cup which is containing some coffee. Now, if I say that the cup has got some coffee and if I ask you to find out what is happening in that cup of coffee, that means I'm not concerned about what is happening outside the cup of coffee, like what is happening here. So if that is the case, I will say this cup of coffee is the system. So that particular part of the universe which is under consideration for thermodynamic study is what is known as thermodynamic system. Now, the entire part of universe except the system is what is known as surroundings. So, I can very easily write that if you have a system and if you have surrounding, And if you are taking into account both the two things, this is what is known as universe. That means if I try to divide the universe into smaller sections, I will say that part of the universe which is under thermodynamic consideration is called system. The part of universe else than system, which we are not concerned about whatever are the heat changes taking place, this is known as surrounding. Now, the phase which is actually separating the system with the surrounding, this so-called thing, this phase is known as boundary. Now this boundary can be real, it can be imaginary. So we'll discuss more about boundary in the further coming slides. Let me move ahead. So if I'm saying here, let's see once again that suppose as per I have taken the example of a cup, here also I say for example there is a system. You can consider this system as a cup of coffee. So what can happen is either in the system you can put some energy, or you can take out some energy from the system. You can do the entry of matter into the system. You can do the exit of matter from the system. That means either heat or matter, they can be either added, they can be removed from the system. So these are the different kind of works which are being done in the system. Now if I move ahead, let's define what do we mean by system. So as per I told you in the previous slide, a thermodynamic system is defined as a definite space or a definite area on which the study of energy transfer and energy conversions is made. This is what I have discussed in the previous slide. What is boundary? The system and the surrounding, as per I told you, these are separated by boundary. Now the boundary either may be fixed, or it may be movable, or it may be real, or it may be imaginary. If I am talking about imaginary boundary, you can take the example that this was a cup. Now here this boundary of the cup is what is real boundary, and it is solid. That means you have a fixed boundary and a real boundary. But this top part, like there is nothing, the air, to separate the air from the coffee, there is nothing. So I am considering a kind of dotted imaginary boundary. And hence, with this example, it has been proved that a boundary can be either fixed, it can be real, it can be imaginary, or it can be movable. So it will not occupy any volume or mass in the space, because it has been assumed that the boundary is such a sleek thing which just separates the system from the surroundings. So it is not asked to occupy any mass or volume in the space. Moving ahead, let us come over to what do we mean by surroundings. I said anything outside the system, but this thing which is outside the system, this is genuinely gonna affect the behavior of the system. This is what is known as surrounding. For example, if I'm taking a cup of coffee and I'm holding it in one of my hands, or so this thing is a boundary, and this thing is the surrounding, and the cup was the system. The other case I can take, I am in my home and I am holding a cup of coffee. So me sitting here and holding a cup of coffee, or me sitting at my home and holding a cup of coffee, the system is still the same but the surrounding is different. So this is all about surrounding. Now let us come over to two conceptual terms. One is control volume. Let me read the sentence for you first. A specified large thermal device. That means if I am taking any thermal device which has been specified, which can have a mass flow in or out of a system, is called as control volume. So the volume over which you are working, once again, which is taken into thermodynamic consideration, is control volume. Simultaneously, if I am defining control volume, on the similar lines I can also define control surface. So in case of control surface, both mass and energy, they can cross the boundary of a control volume, which is called as control surface. Now we can have further discussion on these two things with the help of this diagram. So let me take each diagram one by one. Here in this slide, we are going to discuss something about open system, closed system and isolated systems. Now, as per I have told you earlier, that it's basically the matter and the energy, which we are taking into consideration in case of thermodynamics. Now what happens is, for example, you have just taken a cup of coffee and you have poured some coffee in that cup. Now, you know that the water vapors, so like the coffee gets cold after some time, like you took a cup of hot coffee and you placed it in over a place you have placed it, you will find that it becomes cool. So, we can say that there was an exchange of matter plus energy with the surrounding. Why matter? Because some of the water vapors were moving away from the surface of the coffee into the atmosphere. So this was an exchange of matter, and since the energy has been lost by the coffee cup to the surrounding, that means there was an exchange of energy too. So I can say that any system, again I am taking into account the system, where both the matter and the heat are being exchanged between the system and the surrounding are called as open systems. Now just imagine I covered the top of the cup with a plate. That means after 5 minutes the coffee will be cold, but none of the water vapors are going to escape from the cup of coffee, right? So if this is the case, I can say that if only heat gets exchanged between the system and the surrounding, with no exchange of matter between the system and surroundings, such are called as closed systems. And now suppose I have taken a very good quality thermos flask and I have kept my coffee over there. Then it doesn't become cold after some time, right? So we can say any system in which there is no exchange of matter and no exchange of energy, these kinds of systems are known as isolated systems. I completely agree that none of the kind of thermos flask has been discovered which is 100% acting as isolated, but as an approximation, I can simply take a thermos flask, a good quality thermos flask will gonna be act as isolated system. So I think now the concept of open, closed and isolated system is clear. Let me have a reading of all the definitions one by one. So open system is the one in which both energy and mass cross over the boundaries of system. This is what has been discussed. Closed system is the one in which there is the exchange of only the energy and there is no exchange of mass between the boundary and between the system and the surrounding through the boundary. So these are known as closed systems. And isolated systems are basically those where neither mass nor energy can cross the boundary of the system. So once we are done with this thing, it's the time that we can move over to some good topic. Let's take an illustration. Since we have done something, now we'll go over to some of the examples so that we can understand whatever we have. So we are going to apply the stuff we have understood. He says, water is used as a coolant in the radiators of engine in the motor vehicles because. So what is basically said in the question that once you if you are having a motor vehicle, then in the motor vehicle the radiators the engines. So the radiators of the engine, they are having water as a coolant. Now what is the purpose of water to be used as a coolant? We know that. Now the options which are available to us, the water is having high thermal capacity, easily availability, this is not a correct option for sure. Low density of water is again not going to do anything related to thermodynamics, and low boiling point also. So these are the wrong options. The correct options is high thermal capacity. So now let me first of all discuss what do we mean by thermal capacity. See, if this is an engine, now we know that some work is done by the engine, so there will be heating which will be produced. So there are heating effects and the engine gets heated up. Now if the engine is heated up, so we surround it with a radiator and then you fill water inside it. So now what water is going to do is, since whatever will be the amount of heat released, that will be accepted by water, and water is having a high thermal capacity. This means what? To raise the temperature of water by a given amount, you need to supply a large amount of heat to the water. That means water will act as a good coolant because all the energy, all the heat which will be released by the engine will be absorbed by water, and hence engine can work more effectively. So this was the first illustration. Let me come over to the second illustration, which says that the best material for a cooking utensil is one. Now what you have to do? You have a cooking utensil in which you have kept some food or something which needs to be cooked and you are heating it. So what is going to be the best material to be used as a cooking utensil? It should have high specific heat and low conductivity and high conductivity. This is wrong because high specific heat is not required. High specific heat and low conductivity, again wrong. Low specific heat and high conductivity is the correct option. Now what do we mean by specific heat? See, if you have a utensil and if you are keeping your food over here and you are heating it, now you are cooking the food. So the basic purpose is whatever is the amount of heat which you are providing, that should be going to the food so that it gets cooked up. Now for this thing to happen, you actually need high conductivity. Then only the heat will be transferred from the utensil to the food. So the third option, second part, is okay. Now coming over to the first part, which means low specific heat. Now why do we need a low specific heat? Specific heat is again the same kind of thing, the amount of heat required to raise the temperature of a given body by a particular degree. That means if you are using a utensil which has got a low specific heat, that means what? Only a small amount of heat is required for the utensil to heat up. Now if the utensil heats up nicely, all the heat will be transferred to the food and hence the food can be cooked nicely. So option number C will be the correct option in indicating the best material for the cooking utensil. So now we'll be discussing more in the further slides. So students, this was all about what I wanted to discuss with you people regarding what do we mean by system, what do we mean by surroundings. So since now we are very much clear about what is actually system and surroundings, so the basic part of thermodynamics is now clear to us. I will hope you people to be seen again in the next part where I am trying to tell you about what are the different kind of processes. What do we mean by equilibrium? What are the different kinds of equilibrium which take place in thermodynamics? So hope to see you again in the second part. By the time, take care and start studying.